Hi, sixth graders. How are we doing today?
Doing great.
Doing great.
Great.
Right.
Awesome. Great. Well, today we're going to be working on ratios. And our objectives and standards that we'll be covering today will be 6 RP1, understand the concept of a ratio and use ratio language to describe a ratio relationship between two quantities. And do you guys think you could read this next one with me?
Sure.
Okay.
After watching the Khan Academy ratio video and participating in the goldfish activity, students in small groups will model two ratio examples using the goldfish manipulatives with 75% accuracy on goldfish ratios and closure questions.
Great job, guys. Okay. So, let's see. For our pre-assessment, I have a little question for you. So, what is a ratio? Does anyone know what a ratio is? You can just raise your hand. No? Okay, that's all right. We're going to learn today. We're going to learn what a ratio is. So, a ratio is actually a comparison of two things, okay? So, right up here, we have 2 triangles and 3 circles. Does everyone see that? Mm-hmm. Okay, so so here is our question. So which model represents the ratio of 5 pumpkins to 4 candy corns? So is it 1, count the number of pumpkins and number of candy corns, and just raise your hand when you think you got an answer. Okay, let's see. Marley, what do you think it is?
I think it's number 1.
Number 1? Exactly, right, because if you look, number 1, we have 1, 2, 3, 4, 5 pumpkins, and 1, 2, 3, 4 candy corns. Perfect, good job. All right. So, let's get a little bit more practice in here. So, which model represents the ratio of 4 witches to 6 brooms? We're getting close to Halloween, so I had to give you guys get you guys in the mood. So, yeah, raise your hand, and let's see. Kim, what do you think which picture represents 4 witches to 6 brooms?
Number 2.
Perfect. Good job. Awesome. All right. So, a ratio is a way of comparing 2 numbers. Ratios tell us how much of one thing you have compared to another. And I have a little video that I'll show you guys. It's Khan Academy, so it's one of my favorites. Let's see, I'll get the sound going here.
We've got some apples here and we've got some oranges. And what I want to think about is what is the ratio? What is the ratio of...
Oh, no.
Okay. No, that's all right. We'll get it playing here.
We've got some apples here and we've got some oranges. And what I want to think about is what is the ratio? What is the ratio of apples to oranges? To oranges. And to clarify what we're even talking about, a ratio is giving us the relationship between quantities of 2 different things. So there's a couple of ways that we can specify this. We can literally count the number of apples, 1, 2, 3, 4, 5, 6. So we have 6 apples. And we could say the ratio is going to be 6 to, and then how many oranges do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 6 to 9. Ratio of apples to oranges is 6 to 9. And you could use different notation. You could also write it this way. 6 to, you would still read it as the ratio as being 6 to 9.
Yeah,
But we don't have to
again,
just
notice,
satisfy
pay
us with
attention to
this,
the
because
different ways
one
you
way to
can
think about
represent
ratios, especially if we're thinking about
ratios.
apples to oranges, is how many apples do we have for a certain number of oranges? And when you think about it that way, we can actually reduce these numbers, as you might have already thought about. Both 6 and 9 are divisible by 3. So just how, like we can reduce fractions, we can also reduce ratios. So if you divide 6 and 9 both by 3, 6 divided by 3 is 2. 6 divided by 3 is 2. And 9 divided by 3 is 3. So we could also say that the ratio of apples to oranges is 2 to 3. Or if we want to use this notation, 2 to 3. 2 to 3. Now, does that make sense? Well, look, we divided each of these groups into 3. So one way to think about it, so if you divide this whole total into 3 groups, so one group, two groups, and 3 equal groups, we see that in each of those groups, for every 2 apples, we have 3 oranges. For 2 apples, we have 3 oranges. For 2 apples, we have 3 oranges. So, once again, the ratio of apples to oranges, for every 2 apples, we have 3 oranges. But we could think about things the other way around as well. We could also think about what is the ratio. Ratio of oranges to apples. Oranges to apples. And here we would essentially switch the numbers. The ratio of oranges to apples. Notice, up here we said apples to oranges, which is 6 to 9, or 2 to 3 if we reduce them. And here we're going to say the ratio of oranges to apples. So we've swapped these two, and so we're going to swap the numbers. Here we have 9 oranges for every 6 apples. So we could say the ratio is going to be 9 to 6. The ratio is 9 to 6. Or if we want to reduce it, for every 3 oranges, so we're going to divide this by 3. So for every 3 oranges, we are going to have 2 apples. So notice, this is just exactly what we had up here, but when we had apples to oranges.
Let's see. Did get paused? Then let's see. Just restarted.
We've got some apples here and we've got some oranges. And what I want to think about is, what is the ratio?
Let's try to find.
We've got some apples here. Oranges, for every 2
Okay.
apples, we have 3 oranges.
Here.
But